Hello everyone, welcome back to Smart Entities YouTube channel. My name is Ankit Patel and today we are going to discuss Leetcode Weekly Contest 403 first three problems we'll be discussing. So let's quickly move on to the first problem, that is minimum average of smallest and largest element. So in this problem you will be given an array of floating point numbers, like you will have an array of floating point numbers average which is initially empty. That means he's saying you will be having an array averages which is initially empty. Now we will be given an array nums of length n where n is even. So one more array is given, nums array, where length of the nums array is even here. Okay, you will be given the nums array here, a1 a2 so on, some n where a n is going to be even. Now here he is asking to you repeat the following procedures n by 2 times. He is asking us to do some operation or procedure n by 2 times. What is that procedure or operation? Remove the smallest element, min element and the largest element, max element from the nums. Add min element plus maximum element by 2 to the averages. Okay, we'll be picking the minimum element, we'll be picking the maximum element, we'll be adding the average to the averages, and we'll be removing from the nums as well. Return the minimum element in the averages. Okay, what is the minimum element that we will be having in the here averages array? We need to return that. Okay, let's quickly jump on to the first example. If you look at the first example here, 7 8 here, this is the first example that is given nums array. Initially our averages array, this is the nums array and averages array. Initially average is 0 and nums array is having something like this. Now in this, which is the maximum element here? Maximum would be 15, minimum would be 1. Now to this maximum and minimum, like if I try to find the average, it will be nothing but 8. So I will be removing 1 and 15 from the nums array, and I will be adding the averages to the, like I will be adding this 8 to the average array. Similarly again I will be picking the max element, that is 13, and the minimum element. What is the min element here? 3. So 13 plus 3 by 2, which is again like 16 by 2 would be 8. Again in my average I will be like averages array, I will be adding 8. I will be removing the 13 and 3 from the nums array. This is the now nums array, this is the averages array. Max element 8, min element 4. 8 plus 4 would be 12, 12 by 2 would be 6. So in my averages array I would be adding 6, and this is after removal, this is my nums array. After that only two elements are left, so it would be like 7 plus 4 by 2, which is nothing but 11 by 2, which will be equals to 5.5. So I will be adding 5.5 to the averages array, and I will be removing both of them. So this will become empty now. And how many operations we have performed? Nothing but n by 2 like operations we have performed. And in this averages array, what is the minimum element here? Nothing but 5.5. So we will be returning 5.5 from there. Same with the second example as well, you can go through, but question is straightforward, I guess. Like pick initially our averages array will be empty. Now pick min and max from the nums array, find its average, add it to the averages, remove it from the nums array. But how will I know what is the maximum element? How would I know what is the minimum element? Every time in the nums array, that is the question. Max and min element, max and min in nums. How would I know that? And let's say if I know as well how to remove max and min element in nums, how do we remove max and min in nums? So here one of the logic that we can use here is sorting with two pointers, basically. Sorting with two pointers. So what I mean to say here is, first I will sort the nums array. Okay, initially what all do I have? I have my averages array, which is initially empty. I will sort my nums array. If I sort my nums array, what will be the values here? It will be something like 1 3 4 4 next 1 3 4 4 7 8 7 comma 8 comma 13 comma 15, I guess. That's it. How many elements? 8 elements. Now I have sorted it. Now I will use the two pointers technique. What is the two pointers technique here? I will be pointing one of my pointer to the index 0, second pointer to the end of the array, that is n minus 1th index. So automatically this will be the min element, this will be the maximum element every time. Now once I find the average of p1 and p2, I will increment my p1, I will decrement my p2. Okay, I will decrement my p2. Again I will find the average, find the average, I will add into here. So let's suppose if I am adding first one, so here I will be having 8. Now again I will try to find the average here. Again I will be getting 8. Now once I get it, I will add into the averages and I will move my p1 and p2 pointer. P1 pointer here, I will decrement the p2 pointer. Again 4 plus 8 12, 12 by 2 would be 6. I will add 6 into my averages array, moving the p1 and p2. P1 will be going here, P2 will be going to 7. No, 7, 4 plus 7 by 2 would be 5.5. I will add into average and I will try to. But now if you see what is happening, P1 greater than P2. So we'll stop it here. So what should be my condition here? Till when I am doing this? Till P1 is less than P2. Then only we'll be doing it. Yes or no? And I need to find the minimum in the averages as well. I need to find that. Let's try to code it up the same thing. So here first I need to create a vector of float, say averages. As I said, I will be sorting the nums array here. I will sort it, nums dot begin comma nums dot end. Once I sort it, I need two pointers, one pointer pointing to the like 0th index, second pointer p2 pointing to the end of the array, or I can say n minus 1th index. So nums dot size -1. Till when I will be doing this? Till my p1 less than p2. I will be finding the average here. Let's say average equals to nums of p1 plus nums of p2. I will divide it by 2. But if you divide this is integer, nums of p1 and nums of p2 is in an integer, this is also an integer 2. So we'll be getting the integer value in average every time. So if you don't want to get the average value in integer every time, first thing I need to do is I need to make float average equal to, and here as well I need to write float. I have to make 2 as a float data type. Now once this is done, in my averages I will be pushback, I will say pushback here, average dot pushback average, and I need to find the minimum. So how can I find minimum? In C++ we directly have a function min element. Min element averages dot begin comma averages dot end. This will be giving the minimum element in the average. Okay. Okay. One thing we are missing is we need to increment the p1 pointer every time, and we need to decrement the p2 pointer. And if you don't write that, as you saw, you will be getting the error. Now it is accepted. Now I can submit it. Like here, while we run, we got the correct answer. That's it for the first problem. Okay, let's try to see the second problem, that is find the minimum area to cover all ones. This is the first variation. So here in this problem you will be given a 2D binary array grid. That means you will be given a grid here where you will be having elements 0 or 1. Binary grid you will be given. Now we need to find a rectangle with the with horizontal and vertical sides with the smallest area such that all the ones in the grid lies inside the rectangle. Okay, so we'll be having, as I said, zeros and ones. We need to find the smallest area of rectangle or smallest horizontal and vertical sides where our all the ones which lies in the grid lies inside that rectangle. Okay, find minimum possible area of the rectangle. We need to find the minimum possible area of the rectangle here. Okay, once we see the example, it will be more clear here. Okay, here as here given is a binary grid. Now if you look at this binary grid, and what it is saying, we need to find the smallest area of rectangle which cover all the ones of the grid. See, if I take this rectangle, it does not cover all the ones of the grid. If I take this as well, this does not cover all the ones of the grid. But if I take this one, this covers all the ones of the grid. And what is this area? Area will be nothing but, how do we calculate area of rectangle? Nothing but length into breadth, we can say, width we can say. Here it will be 2 into 3 equals to 6. Okay, length is 3, width is 2. Okay, now let's try to see the second example. Here if you look at the second example, I can take entire thing. This will also cover all the ones of the grid here. But here area would be something like 2 cross 2, which is 4. Does this covers all the ones of the grid? No. What about this one? No. What about this one? No. What about this one? This cover all the ones of the grid. But what is the area that we'll be getting here? Length. Hmm. How much will be getting? Okay. Length would be 2 here and width would be 1. So here we'll be getting as 2. This one, this does not covers all the ones of the grid. What about this one? This covers all the ones of the grid. And area would be 1 into 1, which is equals to 1. Okay. Which is the smallest out of all these? Nothing but 1 here. So we'll be returning 1 from here. Okay. We can take one more example, so that you will be clearly getting the things. Let's say you are having 4 cross 4 binary grid. Elements are something like this. Now, can you guys tell me what is the minimum area of rectangle which will cover all the ones of the grid, given grid here? That would be nothing but this one, simply this one. This rectangle would cover the all the ones of the grid. And what is the area here? Area would be nothing but 2 cross 3 again, which is equals to 6, which is equals to 6 here. One thing we can do here is we can go brute force. We can try to get all the rectangles. Maybe first will be go 1 1 1 1. After that maybe we can go all the something like this again, something like this again 4. That would be brute force and that might give you TLE. But instead of that we can do one more thing here. Now to find the what we are saying, this is nothing but the length here. This is nothing but the width. Now if I know what is first row, what is the row where I am getting my first one here? Okay, do I have one in this row? I don't have. Here I am having the first row. Okay, I am having the one here. Now let's say I am having some, and what is the row that I am having one here? First row, like when I am coming from the top, which is the first row that I am encountering one in that row, and I am encountering one, nothing but the index with one here. Okay, what is the last row that I am encountering one? Nothing but r equals to 2. Can you guys, here I am not encountering one. Now can you guys similarly tell for the column as well? What is the first column where I am encountering the one? Here I am not encountering one. Here in the column 1 I am encountering the 1 for the first time. What about the last one? In the column equal to 3, I am encountering the last one. So once I get this first row, last row where I'm encountering the one, first column and last column where I'm encountering the one, what I need to find? I need to find the length into width. How would I calculate length? How would I get the width here? What is meant by length? Nothing but this one, no? To getting this one, can I say, let's say this is R1, this is R2, this is C1, this is C2. To get the length here, I can simply do is R2 minus R1 plus 1. Similarly, for width, I can do here is C2 minus C1 plus 1. And if we apply, here it is 2, 2 minus 1 plus 1 would be 2 only. And here it would be 3 minus 1 plus 1, which is nothing but 3. I hope the logic is clear. What I am finding here, I am going row by row, getting the first row where I am encountering the 1. I am getting the last row when I am encountering my last one. First column, like I'm getting the column where I'm encountering the first one, I'm getting the column where I'm encountering the last one when I'm going column by column. After that I know how to find the length, how to find the width here. Okay, you can use for loops basically. This is the one logic, like you can go row by row, going row by row, row column, get the R1, again write one more for loop, like nested for loop, get the R2, similarly two more for the C1 and C2, two more nested loop for C1 and C2. All these things can be done, or in a single nested for loop we can find R1, R2, C1 and C2 here. We will be seeing that in code. Okay, let's move on to the code part. Okay, so first I will be getting the number of rows, number of columns. How to get the number of rows, number of columns here? A row would be nothing but grid dot size, grid dot size. Column would be nothing but c equals to grid of 0 dot size. R, instead of writing R1 and R2, I will be writing top, bottom row, left column and the right column. And with what value I need to initialize all this? Top. In top, what we are trying to store? In the top, we are trying to go row by row and we want to store the row where we are encountering the one for the first time. So can I say minimum row? So when we are talking about min, here I need to initialize with into max. When we are talking about the max row or the last row where we are encountering the one, that means we are talking about max. So I have to initialize here with the int min. Same thing I would be doing for the left and right as well. Leftmost, so I will be initializing with int max. Rightmost, so I will be initializing with the int min. I will be writing one nested for loop. Int I equal to 0, I less than r, number of rows I plus plus. Now int c equal to 0, int j equal to 0, j less than c, j plus plus. Okay, here I will be saying if my nums or grid of ij equal to 1, to 1, what should I do? For the top, top equals to top of minimum of I comma top, I would say here. What about bottom? Bottom equals to max of, talking about row, so I comma bottom here. Same with left, left equals to what would I would say min of left comma j, right equal to max of right comma j. As we are talking about a column, I am taking j here. Once I get top, bottom, left, right, I need to get the length, I need to get the width. We have already seen how to get the length, how to get the width as well. Length is nothing but bottom minus top plus 1, and here it would be right minus left plus 1. Okay, okay, however the same thing. Now I can simply return length into width here. Okay, let's try to run the code. Okay, giving the correct answer, we can submit it. That's it for the second solution. Okay, uh, let's try to see the third problem, that is maximize total cost of alternating subarrays. So here it is given that you will be given an integer array nums with length n. The cost of subarray for in that array will be something like for the subarray L2R, like index L2R will be defined as like cost of L comma R equals to nums of L minus nums of L plus 1, so on, nums of R into minus 1 into L minus R. So initially while solving this problem, I also got bit confused with the cost part, but to explain you in the simple terms, cost is nothing. Let's say you are having an array of few elements, okay, a1, a2, a3, a5, a6, a7, okay, something like this. Now let's say this is the subarray you are showing, okay, a4 to a7, l equal to 4, r equal to 6. Now here cost of L2R, which is nothing but 4 to 6, would be A4 plus like A4 minus A5 plus A6 alternatively. Okay, starting with the plus sign, next would be minus plus something like this. Okay, I hope this cost part is clear. Now, what is our task here? We need to split the nums array. We need to split this whatever is the given is the nums array into subarrays such that total cost of those subarrays is maximized. Okay, ensuring each element belongs to exactly one of the subarray. Okay, now I need to divide this nums array into some subarrays. Okay, maybe something like this. This could be one of the option, or other option could be one subarray, second subarray, and third subarray. In such a way that when we find the sum of the subarrays, it should be maximum. Okay, it should be maximum. So formally, if nums is splitted into k subarrays where k is greater than 1 at indices I1, I2, so on, ik minus 1, where 0 less than or equals to I1 less than I2, so on, less than ik minus 1 less than n minus 1, the cost will be something. This thing already we have discussed. Now return an integer denoting the maximum total cost of the subarray after the splitting optimally. After splitting the array optimally. Okay, fine. Completely fine. Here one note is also given. If nums is not splitted into k subarrays, like if nums is not splitted into subarrays, that is k equal to 1, the cost of the total cost is simply cost of 0 to n minus 1. Fine. He's saying that, let's say we are not splitting the array into some, like this is one subarray, this is one subarray. If we are not splitting like this, automatically this will split it into each element as a subarray, and the total cost would be adding all the elements here. Okay, let's try to look at the example, then it will be more clear for you. First example, here in the first example given is elements are 1, minus 2, 3, comma 4. What are my options here? See, I can divide them into something like this as well. Maybe of first of length 1, let's say. So what will be my cost? Cost would be something like 1, because here 1. Now 1 plus minus 2, it would be single again. So 3 plus 4, which is nothing but how much? 1 minus 2 would be minus 1. Here 2, 2 plus 4 equals to 6. Okay. Okay. Again, let's try to divide the arrays, split the arrays here. Maybe something like this. Now when I split something like this, as this part of the one subarray, what will happen? This will become L, this will become R. And how I will be finding the cost of this subarray? That would be nothing but 1 plus 1 minus of minus 2, which will become 3 here. This subarray cost would be 3 here as well as 3. This is 4, which is nothing but, let's say this is answer 1. Then my answer 2 would be 10 here. What are other options here? Instead of dividing like this, maybe I can divide something like this. LR and this is separate. Now when I divide something like this, 1, again minus of minus 2 plus 3, this cost would be 6 here and this will be 4. Again answer 3 as well as 10. I can take entire thing like entire array as a single subarray, then my cost would be 1 minus of minus 2 plus 3 minus 4. Okay, L and R would be here. In that case it will be 3 plus 3 6, 6 minus 2 would be 2, which is answer 4. And out of all this, which is maximum here? See, I have other options as well. Maybe something like this also I can do. Okay, but till now if I see A1, A2, A3, A4, my maximum answer is 10. So, and it is possible that we cannot get more than 10 here, maximum sum more than 10. So we'll be printing 10 here. What about the second example? Same thing is happening. How here it is dividing? Something like this. Okay, this would be 2, this would be 2, which is nothing but 4. Single element, no need to do anything. Okay, let's try to have these things apart. Okay, let's say I'm having a nums array where I'm having elements something like this: A1, A2, A3, A4, A5, A6, A7. Now let's say if my all the elements of the nums array were positive, okay, all the elements of nums array were positive, can I say that my answer would be simply nothing but the sum of the nums array here? Sum would be my answer, but that is not the case. We can have here the negative as well. Okay, negative elements as well. Okay, let's say I am at some particular element A3. What are my choices? It can be positive as well, it can be negative as well. When this element is positive, can I say that I can take this A3 as a subarray, having the single element A3, and I can add into my sum. But what about when it is negative? If I take this as a subarray having only single element A3, when it is negative, then what will happen? So as it is a negative number, the sum will get reduced. Yes or no? Let's think in a greedy way. Okay, when it is positive, I will directly add into my sum. But what about negative? What I need to do when it is negative? If I simply add into my sum, it will give me the, like, it will reduce my sum here. So what are my better options? To convert this A3 into positive, to convert it to positive. How can I convert it to positive? We know that if I take a subarray of some length, what are my operations? How I am performing? First I am applying the positive, then negative, positive, negative. And I know that when I multiply negative with negative, it will convert into positive here. So can I say that here I will be depending upon the previous element for the negative? I will say that instead of creating a array of only having the A3 element, I will be creating an subarray having the A2, A3 previous element as well. Now when I am having a subarray something like this, A2 and A3 element, now can I say that my sum would be A3 minus of A2 minus of A3. Now as A3 is negative, whatever the sum I will be getting from here, it will increase my sum only. Yes or no? It will increase my overall sum. This is in a place of thinking when we are thinking in a greedy way. But let me give you an example where this might fail, like whatever the assumptions we have made till now will be failing. Okay, let's take an example of element something like 3 minus 2 minus 7, something like this. Okay, 3 minus 2 and minus 7. Okay, let's say if I divide these, if I okay, if I am dividing this in a some part, let's say this as an entire subarray, what will be my sum? Sum 1 would be, if I'm taking this as an entire subarray, it would be like 3 minus. Okay, let's try to take one by one. Okay, if I'm taking single one, so it would be like 3 minus 2 minus 7, which will be nothing but minus 1 minus 8. Okay, no, let's not take the single one. What we were thinking till now, if it is positive, we will be directly taking it. When it is negative, I will make the subarray of length 2 here. Let's try to do the same thing. This has a single subarray, this is another subarray here. So what will be my sum 2 here? Sum 2 would be nothing but 3 minus of minus 2, another subarray, plus minus 7 here. Yes or no? This is the separate subarray, so it will be something like this. Now this answer will be minus 2. Yes or no? Can I say that whatever we were thinking till now, it will be failing here? Yes or no? It is failing, because whenever I am getting a negative number, if I consider the previous element into my current subarray, it is not guaranteed that every time you will be getting the maximum sum. As you look at here, I am not getting the maximum sum. When I will get the maximum sum? When I consider this entire as a subarray, this entire array subarray, or when I consider this as a one subarray and this is a another subarray, I will be getting the maximum sum. So sum 3 would be 3 plus minus 2 minus of minus 7, which would be nothing but 3 plus 7 minus 2 would be 5 equals to 8. Yes or no? So sum 3 is giving us the maximum sum. Here answer will also be the 8 only. So it is not guaranteed that always this will be giving you our answer. So here greedy will fail, but when greedy fails, we can apply one more thing, that is the DP here. And what are my options here? See, basically we are having two options. Okay, option 1, what are my options? 1, when it is a positive element, I can directly create a subarray of length 1. Or what are my option 1, I can directly take into my sum here. So whatever I got till previous I minus 1, to that I will be adding my nums of I here. That is my option 1. What is my option 2 here? Option 2, what is my option 2 here? Option 1, option 2. Option 1 was directly taking into the sum whatever we were getting till previous index. Option 2 would be something like, now as it is, whatever we got till I minus 2, and consider current element plus previous as a one subarray. Yes or no? Current plus previous plus current as a one subarray. And if I do so, can I say that my option here would be, option 2 would be I minus 2 plus nums of I minus 1 minus of, or minus 1 into nums of I, having two options basically, option 1, option 2. Generally, if you have solved the DP problems, we have a one variation called as a take non-take, take non not take. Same thing here as well. Option 1, option 2, we need to validate. Okay, option 1, option 2, we need to validate. So first I will be creating a DP array of size n plus 1. Here running a loop, we'll see that later. going till n I plus plus. What are my two options here? I can say my option 1, option 2. Option 1 would be whatever I am getting till previous, whatever I am getting till I minus 1 plus nums of I. Second option, I minus 2 plus nums of I, nums of I minus 1 minus 1 into or minus of nums of I here. Okay, now I can say here just dp of I equals to max of option 1 comma option 2, as we want to maximize our answer. At the end we can return the dp of n. This is the entire code. I hope everything is clear. Two options, directly take, or whenever we are not taking it directly, I will be considering current plus the previous element as a one sub array, and I will be doing that. Okay, let's move on to the code part. Okay, first I will be getting the size into n equals to nums dot size here. I need to create the dp 1ddp as well, vector long dp of okay, already have taken n plus 1. Initially everything would be 0. I will be saying dp of 1 equals to nums of 0. Now I will be going till I will be starting from the second, like I equals to 1. I will be going till n. Now what are my option 1? As we have discussed, option 1 we are having the option 2. Option 2 here, and in my dp of I will be having max of option 1 comma option 2. At the end we need to return the dp of n. Okay, let's try to write what are my options 1 here. If I am taking it, I will be saying whatever I got till now plus nums of I. If I am not taking it, so whatever I got till previous nums of I minus 1 and minus of nums of I. We can try running the code. So as we are taking everything as one base indexing, so I have to place it here I plus 1 here. I will be running the code. All test case passed here, then we can directly submit it. Okay, here option 1 and option 2, we need to take it as a long here. That is the thing we are missing, I guess. Let's try to submit one more time. It is accepted. That's it for the third problem. And if you found this video was informative, do share with your friends. For more such content, like, share, subscribe to Smart India's YouTube channel. Until next post content discussion, this is Ankit Patel signing off.